drying. 9. Fluidized bed drying and granulation is a widely used technique in industries like pharmaceuticals, food, and chemicals. It involves fluidizing particles with a stream of air or gas, which simultaneously dries and granulates materials. This method offers uniform drying, enhanced product flowability, and controlled particle size. Questions and answers. Question 1. What is fluidized bed drying and granulation, and how does it work? Answer. Fluidized bed drying and granulation involves suspending particles in an upward flow of air, creating a fluid-like state. This technique dries the particles evenly and allows granules to form by adding a binding solution. The airflow dries the binder, consolidating smaller particles into larger, uniform granules. Question 2. What types of materials have you processed using fluidized bed drying and granulation? Answer. I have processed materials like plant-based powders, probiotics, and bioactive compounds using fluidized bed drying. In my work with turmeric extracts, I used this technique to create uniform, free-flowing granules that improved the stability and handling of curcumin powders for food applications. Question 3. What are the advantages of fluidized bed drying over other drying techniques? Answer. Fluidized bed drying offers uniform drying, shorter drying times, and the ability to granulate particles simultaneously. The process enhances product flowability, which is particularly beneficial for powders in pharmaceuticals and food industries. It also allows precise control over particle size and moisture content. Question 4. What challenges have you faced with fluidized bed drying and granulation, and how did you overcome them? Answer. Challenges include particle agglomeration and inconsistent granule size. To overcome these, I optimized binder addition rates, air velocity, and inlet temperature. I conducted trials to adjust process parameters, ensuring uniform granulation and minimizing agglomeration while maintaining product quality. Question 5. How do you optimize process parameters in fluidized bed drying and granulation? Answer. Optimization involves adjusting variables like air velocity, temperature, binder solution concentration, and feed rate. I use small-scale trials to identify the best conditions for the material at hand, ensuring that the drying rate is efficient without causing overheating or poor granulation quality. Question 6. What role does the binder solution play in fluidized bed granulation, and how do you select it? Answer. The binder solution helps particles adhere during granulation. The choice of binder depends on the material's properties and desired product characteristics. In my research, I selected binders like starch or maltodextrin for plant-based powders to ensure stable, uniform granules without compromising bioactivity. Question 7. How do you ensure uniform granulation and drying across a batch in a fluidized bed system? Answer. I ensure uniformity by controlling airflow, bed height, and binder spray rate. By monitoring these parameters in real time and conducting pre-process trials, I can ensure even drying and granulation throughout the batch. Consistent temperature and airflow distribution are crucial to achieving uniform results. Question 8. What analytical techniques have you used to evaluate the quality of fluidized bed-dried and granulated products? Answer. I've used techniques like particle size distribution analysis, moisture content measurement, and scanning electron microscopy, SEM, to evaluate granule structure and quality. Additionally, I've assessed flowability and dissolution properties to ensure the final product meets functional requirements. Question 9. How do you prevent common issues like particle agglomeration or excessive dust formation during fluidized bed drying? Answer. To prevent agglomeration, I carefully control the binder application rate and ensure even airflow. For dust formation, I use anti-static agents or adjust the drying air humidity. By fine-tuning these parameters, I can minimize both issues and maintain product quality. Question 10. Can you describe a project where fluidized bed drying and granulation significantly improved the end product? Answer. In one project, I used fluidized bed drying to encapsulate and stabilize pumpkin seed oil in a powder form. This technique allowed for the production of free-flowing, stable granules with enhanced oxidative stability, improving the oil's shelf life and ease of handling in food applications.